Hello everyone, my name is Rishabh Gupta. In this video, we will cover the module 2nd and 3rd of our data science assignment. The module 2 covers the whole data preparation. As the name suggests, the data preparation topic revolves around the idea of preparing our data for further study or further refinement, such as arranging it. And for arranging it, we use indexing, like arranging it in a numerical manner, and things like re-expressing the data, removing any misleading values, identifying any misleading values, or identifying any outliners. Outliners are the data which deviate from our basic mainstream data too much. Like if we take average with a outliner, the outliner will affect the average value by so much that the rest of the data will stop making any sense. This module has 5 questions. First of them being how to add an index file. We have a program to explain this question. So our second module first question is how to add an index file in Python. Now we have a list of subjects here. Data science, we have 5 subjects here, and we are indexing this data using this index subject variable, where we have the our list enumerate function where subjects is being indexed. And the start is for where do we want the indexing to start from. Like I have written 67, and if I run this code, it will start indexing the data from 67. So it basically controls what is going to become. If I write one and run the code again, then I get the index from 1 2 3 4 5 as per our requirement. So our next question is how to change misleading field values. So any misleading values, such as if you take an example that age is in negative number, you cannot really use that value anywhere, because you know that it is not time if time is given in a negative number. So the values that you know that will not be any further useful for you are the misleading values, and you should replace them with some user defined variable, such as not available or any sort of user defined variable. We are using pandas library here. So we have this name, age and gender information about our data. And here the first is name Rishabh, and then the age is 25. That is fine, the gender could be male. This information is correct. But the next one, ABC, this seems to be a false entry, because the age is in negative, and we know that age cannot be negative. So as we run this program, we get the before and after. Like the original data frame was Rishabh, age 25, and then gender M. But if we see now, the modified data frame has the same value, because this was a valid entry after all. But as we see the ABC, where the age was negative, it has replaced it with a user defined variable which was NA, not available. So this is how do you change misleading values. And now the third topic is how to re-express categorical field values. We have a program to explain this as well. As we have our different items, such as apple, banana, orange, bread, milk and eggs, they all fall in different categories, and we have to categorize them. So we are again using the pandas library. If I run this program, we get this. Sorry, our items are apple, banana, orange, bread and milk. But if you express them together, so now the apple is fruit, banana is fruit, orange is fruit. So it's basically telling you re-express data set. You had the original data set here, but after re-expressing it, you have much more clear view of what these elements actually are, such as apple, banana and oranges are fruits, and the bread falls into the bakery category, and the milk and eggs are your daily needs dairy category. So this is basically how do you re-express categorical field values. So the next question of our module is how to standardize numeric fields. So basically what standardizing numeric field involves transforming the data to have mean of 0 and a standard deviation of 1. That means we are focusing data into one direction. We can show this with the help of example. This is our standardization. So if I run this program, all this data here, feature 1 and feature 2, will be standardized in a certain direction. Here, like original data set was this, but after standardization, it is in a mean deviation. Our next topic is How to identify outliers using Python. Outliers are uh, Outliers are those values which affect our data mean by a very large amount, like such as if we have data like this 10, 20, 30, 40, 50, we observe that 200 is the gap between all values is 10 in different cases, but in case of 200 it's very much. If we take the mean of these values, the 200 will affect the mean of other values too. So these type of values are called outliers. Now we understand it as it is, but in a Python program we use the pandas library, import the pandas library, and it tells us that the outliers is the 200 and its index is 5. We use this absolute z score is greater than the threshold. We set a threshold of what the gap between values should be. The Now we are going to move into the module third of our assignment, which is EDA, exploratory data analysis. EDA relies heavily on defining your own trends in data. It does not use any previous hypothesis. It visualizes the data and finds any new trends in it. The first one is how to construct a bar graph with overlay using Python. To understand this, we will go into our programs, bar graph. Now, once we run our program, in each category, we have three categories with different data values. If we run this program, we will get a bar graph of our values that will help us visualize the data. And with this visualization, we can find any new trends that were not seen with the numerical data. So this is it. This is our visualization of this bar graph, as we can see here. This Now this helps us to find any new trends that we could observe by just visually looking at the data. Now the next topic will be how to construct contingency tables using Python. Contingency tables just frequencies, divide the categories as per frequency, like how many times an entity has occurred in our data. For this, our program is this contingency tables like A, B, C, B, A, and the A falls into category X. How many A's fell into the category X? How many A's fell into category Y? That sort of, yeah, this like our unique values in category A, B, C, unique values in category 2 are X, Y, Z. So A occurred in X one times, A occurred in Y two times, and for Z it was nowhere to be found. So this is how our contingency table creation works. Now overlaid histograms or bar graphs using Python. Yeah, this sort of overlay happens whenever in our data set 1 and data set overlaps, and we can study about it, like how much it is overlapping, how much the one affects the other, is the overlay of data with histograms. How to perform binning based on predictive values in Python. Binning is just grouping continuous numerical data together for our analysis and relationship between the variable and data. Like our program here, it has quantities 0, 0.25, 0.5, 0.75, and then 1. After we bin it together, they are all in a certain range. Like the ranges are, our values were 0.01, 0.25, then 3, every other value, and now it is binned into a category in like, if we look at the definition again, binning based on predictive value involves grouping continuous numerical data into smaller intervals. So if we look at the intervals here, so the whole process is called binning.